All right, class. So as we look at another strategy in solving these kind of problems where we're dealing with proper and improper fractions and multiplying them together, another strategy is combining ones we've already done. What I mean by that is, sometimes looking at the fractions we have and simplifying them before we draw a picture actually helps. So what I have here is, number one, I simplify either of my two fractions. And if I look at 5, 6, I can't simplify that. There's no common factor that will go into 5 and 6 besides 1, so that wouldn't reduce it to simplified terms or simplest terms. But 12 fourths, this fraction here, I can't. And I want to think of the largest or highest common factor that goes into 12 and 4. And I happen to know that 4 goes into both of these. So the thinking I'm kind of doing off on the side for this one is if I have 12 fourths and I divide by that largest common factor, which is 4, I'm going to get 3 over 1. And I want to leave it as 3 over 1. So I can do the work for the next part of my fraction here. So, or finding my parts of, if you will. So I'm going to erase 12 fourths, and I'm going to replace that with 3 over 1. Now, when I get a fraction that looks like this is a pretty easy one to draw. It means I have 3 wholes. Right, so I have 1, on this. There's my second whole. That's my third. Right, so that picture there now represents my 3 over 1. Hopefully this is going to make my drawing of my pictorial representation a little easier. Right, so I've got 3 parts. Just like I've done before, I'm going to take my dotted line, and I don't need to split it because I have 3 holes, and so the part I have is 1, so I flip my boxes show 1 part. Now I'm going to draw horizontally across, and I'm going to try to draw 6 equal parts. So 1, 2, 3, 4, 5, 6. Right, so each one of these represents a 6 of, that's better, and I need 5 out of those 6. So again, if I were to do my shading and I just take one, I'm going to shade 5 parts. So a little messy, but to get the idea. So I can do that with the mouse. So there's 5 out of 6 parts. Now, if you think about the work I've done, I've only done that for 1 out of my 3 holes. So I would need to repeat that for all the others. So I'm actually going to sort of lay this over the top so I get a pictorial representation. So you can clearly see what I have here. Right. So as I look at my picture now, I know that if I look at one rectangle, it takes 6 parts in order for it to equal 1 whole. Right. So 6 parts within any one whole rectangle, which represents one of my 3 holes. Now I need to look at how many parts I have in total. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 parts, and it takes 6 parts equal any one whole. So what I'm going to do here is I'm going to simplify this, and I know 6 goes into 15 3 times. Excuse me, 2 times. And I have 3 left over, and 6 parts makes my whole. Or if I simplify it one more time, my final answer is going to be 2.5. So if I find 5/6 of 3, well, 5/6 of 3 is equal to 2.5, and that's what my picture shows. So another way to think of this is if I took 1/5 from the second whole and shaded in this, I get 1 whole. If I took 1/6 from this, I moved it here, another 1/6 from here, I moved it here, I would actually get a picture that would look like 2 whole rectangles and 3 out of 6 parts here, or 2.5.